Okay, let's dive right into this. I want you to close your eyes for a second and picture the global ocean. Don't just think of it as a huge body of water, but imagine it as a giant, bustling, solar-powered city. Right up at the very top, in the penthouses, you've got this incredible abundance of light, powering everything from the absolute smallest plankton all the way up to the largest whales. But recently, marine biologists have spotted a deeply concerning trend. As you travel down to the lower floors of this underwater city, well, the lights are mysteriously burning out. So today, in this explainer, we are unpacking the really alarming phenomenon of ocean darkening.
Imagine waking up tomorrow, looking out your window, and the sun simply couldn't penetrate the atmosphere to reach your neighborhood. Sounds like a sci-fi movie, right? But for the marine ecosystems that rely on this sunlight to hunt, hide, communicate, and even reproduce, this isn't just some hypothetical thought experiment. It's a very real, rapidly unfolding ecological crisis.
And to really grasp the sheer scale of this, you only need to know one staggering little number: 90%. That's right, 90% of all marine life on Earth lives in the exact region of the ocean that is currently losing its light. We're not talking about those deep, dark, abyssal trenches where, the bizarre creatures with the glowing lures live. No, we are talking about the most vibrant, life-filled real estate on the entire planet.
We're talking, of course, about what scientists call the photic zone. Now, keeping it simple, this is basically just the top 200 meters of the ocean where the sunlight actually reaches. It's literally the biological engine room of the sea. It drives the photosynthesis that ultimately feeds billions of people and honestly regulates our entire global climate.
So, just to do a really quick recap here to lock this in, the ocean is basically our solar-powered city. 90% of marine life lives right up there in the sunlit photic zone. And crucially, the ocean is getting darker. The stakes couldn't be clearer, but the big question is, why?
Section 1. What causes ocean darkening?
Now, what's really interesting about this slide is the sheer, mind-boggling scale of the problem. If you look at the red areas here, they show exactly where the global ocean has measurably become darker over the last 20 years. This isn't just some computer glitch, and it's definitely not an isolated incident. We're looking at a massive, observable global shift backed up by 2 solid decades of satellite data.
So how does this actually happen? Well, near our coastlines, the mechanics are actually pretty straightforward. First, you get nutrient-dense runoff from land and agriculture washing straight into the sea. That acts like a giant dose of hyper-fertilizer. This massive nutrient spike fuels these explosive algae and plankton blooms. And these blooms end up spreading out like a super thick, dense forest canopy right across the surface of the water, completely choking off the sunlight to the ocean below.
But here's the real twist. It isn't just a coastal runoff problem. The open ocean is darkening too. Why on earth is that happening? Well, it turns out that warming global temperatures and shifting ocean currents are fundamentally altering the ecology of the open sea. As surface temperatures change, it alters phytoplankton concentrations far, far away from the shore. So that canopy effect we just talked about? Yeah, it's spreading across huge, vast swaths of the deep, open ocean.
Okay, quick recap on our prime suspects here. Coastal runoff enters the sea and feeds these massive algae blooms. Those blooms act exactly like a thick canopy, blocking the sun. And thanks to global warming and shifting currents, this whole problem is expanding way out into the open ocean.
Section 2. The biggest daily migration.
Let's move to the next bit and see how this builds. Now that we know why this is happening, let's look at who is actually getting hurt. We aren't just looking at darker water. We are literally looking at compressed, shrinking habitat. This global map shows how much the photic zone depth has physically shrunk. Scientists actually track this using these tiny creatures called calanus copepods. They're these little crustaceans that rely on extremely precise light levels to hide from their daytime predators.
And the incredible thing is the daily up and down movement of these tiny creatures, along with other zooplankton, is literally the largest daily mass migration of biomass on the planet. Every single day. Under the cover of darkness, they swim up to feed, and when the sun rises, they swim back down to hide. But as their safe, dimly lit habitat shrinks and gets compressed toward the surface, they're being forced to spend their days in much shallower waters. This dangerous habitat compression threatens to completely disrupt the entire global food web. We're talking about impacts on everything from major fish stocks to the Earth's carbon cycle.
So just to recap this segment really quickly, zooplankton migrate vertically every single day using light cues. But darker waters are compressing their safe habitat. And this massive disruption absolutely threatens the gigantic ocean food webs that, frankly, we all depend on.
Section 3. Moonlight, corals, and spawning. Have you ever thought about how important moonlight is underwater?
Seriously, it isn't just the sun that matters down there. Moonlight acts as a totally vital biological clock. When scientists contrast the massive, huge loss of daytime sunlight depth with the depth loss of nighttime moonlight, sure, the total volume of water losing moonlight is naturally a bit smaller, But biologically speaking, the loss of that delicate lunar penetration is just as ecologically devastating.
So the crucial point is this. It is especially critical for sessile species. Those are species stuck in place, like corals. They rely entirely on super delicate moonlight cues to trigger their annual mass spawning events. And because they're literally cemented to the seafloor, they can't just up and swim toward the surface to find better light. If that darkening water blocks the moonlight signal, their entire reproductive cycle is completely 100% jeopardized.
Here's the quick recap on our nighttime impacts. Nighttime light levels are shrinking right alongside the sunlight. Corals absolutely rely on that moonlight to trigger their spawning, and because they can't move, their ability to reproduce is severely at risk. It's a huge threat to these vulnerable reef ecosystems. Section 4. Myths about ocean light. Okay, let's clear up some misconceptions, because the biggest myth out there is that this is just some localized, dirty coastline issue. The reality? 20 solid years of scientific data proves that over 21% of the entire global ocean has measurably darkened. Think about that for a second. That is more than a fifth of the total ocean surface on Earth experiencing a fundamental shift in how light passes through it.
And this brilliantly illustrates the true depth of the problem. The data shows that nearly 10% of the global ocean has lost 50 meters or more of its life-giving light habitat. Just imagine an entire 15-story building's worth of water depth spread out across 10% of the entire globe, just plunging into darkness over just 2 decades. It represents one of the absolute largest, fastest habitat losses on the planet, and it's happening entirely out of our sight.
So one final quick recap. Make no mistake, ocean darkening is a massive, massive global issue. We have lost up to 50 meters of light depth in vast, vast areas of the sea. And it truly represents one of the largest silent habitat losses on Earth today.
Which brings us to the ultimate million-dollar question. If 90% of marine life needs this light, how on earth will the ocean adapt to living in the dark? The food webs are compressing, the ancient moonlight clocks are fading. It's like a giant puzzle we are going to have to solve, and quickly. Thanks so much for joining me on this explainer today. Keep asking those big questions, and I'll catch you next time.